I wanted to talk briefly about experimental work. So let's talk about physics experiments. You will be required to do labs in this course. Many of the labs are open-ended. I'll pose a question and you will go with it to try to answer that question. But you will have to write up a lab report, and let's talk about the format that you can use. This is format 1. You do want to have a title for your lab. Definitely include a title. Try to make it interesting. You also want to state the aim of your lab. You also should talk about any theory associated with your lab. You may have to do research on this and how you're going to apply that theory or expand on it from what you're doing in the lab. You do want to talk about your procedure, exactly how you did the lab, what materials you used, and so on, what steps you took. You might want to take pictures of your setup and put these in your lab. A picture is a great way to show exactly what you did and how you did it. You also want to include your measurements. Now, you usually will display these in a useful way, like in a table. You also will take this information and analyze it. And that's what the last part is, your results and conclusions. You should have graphs. You should have methods of analyzing your data. You should clearly state how you're analyzing your data. You should do calculations here. You should interpret your graphs. Don't let your reader interpret your graphs. You tell the reader what you want them to see. So if it's a linear relationship, it may be obvious, but you should talk about what relationship you want them to realize. So title, aim, theory, experimental procedure, measurements, results, and conclusions. I also will give you a sheet with questions, additional questions, addendum questions. Typically, I give these at the beginning of the lab, and I have a few here I'm going to pose for you for this particular lab. And I want you to answer these to the best of your ability. Sometimes these questions don't have a clear answer, but I want you to give it some thought and give it a thoughtful answer. You also can talk about these questions in your lab. It can also lead to deciding on how you're going to conduct your lab or what you're going to look for, or what questions you're going to try to answer. Usually there's a burning question that you're trying to answer, and it drives you to do the experiment. You're trying to figure out a way to answer that question, and you're trying to use science to do it. You're trying to conduct an experiment to verify either a result or to see what happens and try to explain it later. So there's also a second format. I like this format myself. You have a title. You have an abstract. It's a brief summary of your lab, what you did and what the results were. A lot of times when you're doing research and trying to find out what has been done, you'll read abstracts to see if it's a paper you want to read. This is a very standard way of writing an official on a lab report. You do want an introduction. The introduction usually includes the aim and the theory. The experiment will be the procedure and the measurements. And then finally, you have the experimental results and discussion. You always discuss your results. Don't leave it up to your reader. You should draw conclusions and maybe pose additional questions that need to be answered. Any problems you had with the experiment and so on. And there will also be addendum questions. I will add these to the lab. Now, for the very first lab, I'm going to use a phrase from Shakespeare. There's a lot of physics in when you read Shakespeare. Lots of phrases he uses bring up concepts in physics. You could design labs around these concepts. One of the concepts deals with shadows. There is a phrase in one of his plays, and the phrase is this: swift as a shadow. And you probably heard this phrase before, as swift as a shadow. And the question is, well, what does he mean by this? Like, how swift or how fast can a shadow move? I mean, can you make a shadow and then move it and test how fast you could actually move this thing called a shadow? So what I would like you to do is develop an experiment involved with shadows and investigate how fast they can actually move. So here's what you're going to do. And this is an open-ended lab that I would like you to participate in. So as swift as a shadow. You want to investigate the possible speeds of a shadow. I know we see shadows every day. You do see shadows move. If you watch how a shadow is created by the sun and how it moves throughout the day, you're probably aware that you could use that as a way of measuring time. You could create a sundial. But I want you to think about, if you purposely are moving a shadow, how fast could you actually get it to go? Is there a limit? And, you're going to have to decide on, well, exactly what is a shadow? How do you produce it? So you must create a shadow. You want to make it move somehow, and then you want to measure its speed. Now, when you measure something, you're doing physics. A lot of physics is about how do we measure something and what are we measuring. And you're going to be trying to measure the speed of a shadow. And if you remember what speed is, it's total distance traveled over time taken. So you have to have a way of measuring distance and measuring time. You might use a ruler for distance. You might use your cell phone, the stopwatch on your cell phone, to measure time. But you have a natural reaction time, so you're limited to, what you can measure. You want to conduct the experiment in such a way that you can actually measure these things and then interpret your results. So try to make a shadow that moves as fast as possible. You can start off with slow speeds, medium speeds, and then try fast speeds. But the trick is you need to be able to measure this. So you need to come up with a way of measuring the speed of the shadow. And the goal is to make it move as fast as possible. And then speculate how fast it could actually go. So definitely speculate. Whatever you say, it should be based on your data, on your observations. It should be logical in that sense. You want to write up a lab report. I'm actually going to give you some sheets to fill out. This doesn't have to be a major lab report at this point. It's just to get us going. I do want you to include answers to some questions. I will pose them here in this PowerPoint. And I want you to not only write this up, I want you to, or fill out these papers I'm going to give you. I want you to include your rough data sheets. This is when you first write down what you're measuring. You might have a notebook, a lab notebook, where you write this in. You have pictures, you have information about your setup, and later on you take that and you use it to make a nice professional report. I'm going to give you some experimental sheets that you can fill out at this point, but later on you are going to have to write an official lab report. So you also want to remember to discuss any current theory on motion, on any current theory on limits to speed, or anything about shadows. You'll have to do a little bit of research for this. Google shadows, Google, the upper speed of a shadow. Can a shadow move? All kinds of things you could think of. Now, I thought of, and I believe this is actually already done. I thought of creating a cell phone that functions on communicating with shadows. But you're going to have to do some research. What do you think I mean by shadows? If I was going to use a cell phone to communicate with shadows, and I bring up another question here. Can you communicate with a shadow? Could I communicate with shadows? And how fast could I communicate? Is there a limit to the speed of a shadow? I want you to think about these things. Perhaps we could develop a technology that actually uses shadows. And then again, maybe there is a technology out there right now that uses shadows to communicate. I could call my device, I could call it the shadow phone. Think about that. So here are the addendum questions. I'm going to put them right here. Very first one, I want you to discuss the possible answers now. The possible answers in your lab report. I want you to discuss the highest possible velocity for a light spot or shadow. Now, shadows are associated with light, if you haven't already guessed. Now, a light spot would be kind of like the spot that's produced by a little laser. A lot of us have had those little lasers on the tip of a pen where we can point at things. What would be the highest possible velocity, or you could say speed, of something like this? What is the lowest speed you have observed? Now, based on your observation, what is the lowest speed you have observed? How small is it? Give me a number. And is there a lowest speed in nature? Is there a speed that it's not at 0 meters per second? It's above 0 meters per second, but it's considered the lowest speed in nature. What would that be? Also, can something stop moving? And how would you show it? How would you show something is not moving? Can something stop moving? Another question you could consider, can the universe move? If you think of the universe as only the Earth with synchronized clocks, that's your reference frame. But when I say the universe, I mean beyond the Earth. I mean including the moon, the planets, the stars, and so on. Everything in the universe that we can observe, the observable universe. Can it move? Think about that and answer this question to the best of your ability. None of these are possible answers. Is the motion of a shadow an example of motion? I mean, we're studying motion and we're trying to pin this down, like what is motion? And the more you know about what it is, you'll be able to answer this question. Is a shadow an example of motion? When you make it move or see it move, is it really moving? Is that an example of motion? Think about that. And another one, would we observe motion if we had no memory? There are people that suffer from dementia, and the question is, can they still, someone that can't remember, what just happened 5 minutes ago, would they observe motion? Do you need memory to observe motion, or would there be another way to observe it, even if you couldn't remember? Now here's a picture by an artist. They're using the shadow of those letters on the wall. I believe this is in Japan, and it creates this silhouette of a person. The light, I believe, is to the right, and you can see the silhouette to the left. That's kind of interesting. Here's another one. Can you see the face? I would say this is a form of communicating. So what I would like you to do, I want you to start this lab. It will